This is exercise 5 on similarity, and again in this exercise they are asking us to prove that the ratio of two sides is equal to the ratio of two sides of two triangles that are similar, but then we don't know which triangles those are, and we don't know their corresponding angles and their corresponding sides. We are required to prove that when you take length AE and divide it by length CE, you get a ratio that is equal to the ratio that you will get if you divide side AD by side BC. But we don't know the triangles of these sides, and we don't know their corresponding angles. So from this, we need to figure out which of those triangles are they referring to. So what I usually do is I focus on one fraction. So I have AEC. Is that a triangle on our diagram? AEC. No, it's not. It is no. So on our second fraction we have ADB. Is that a triangle? ADB. No, it's not. ADC. ADC. No, it's not a triangle. So I have failed to determine the triangles by looking at the individual fractions. So what I'm going to do is I'm going to focus only on the numerator. So I have AED. Is that a triangle? AED. Yes, there is a triangle that is named that we can call AED, triangle AED. Now let's focus on the denominators. We have CEB. Is there a triangle named CEB? CEB. Yes, we have triangle CEB. So now we have identified the pair of triangles that are compared, or that we need to prove that they are similar. But then the naming is totally wrong, because we know for sure that the angles of these triangles do not correspond. So we need to figure out how to name these triangles correctly so that their angles correspond and therefore their sides will correspond. So we need to look at our diagram and see we have triangle AED. AED, so the bigger triangle, and we also have triangle CEB, the smaller triangle. So since ABCD is a cyclic quad, we can say angle C2 is equal to angle A, because angle C2 is an exterior angle of a cyclic quad. It is equal to the opposite interior angle. So we have just made our first pair of corresponding angles between our two triangles. So we have angle C is equal to angle A. So now let's look at our diagram again. We have angle B, and angle B is an exterior angle of this cyclic quad, so it must be equal to angle D, because angle D is the opposite interior angle. So we have angle B2 being equal to angle D. And now what about angle E of this triangle and angle E of the bigger triangle? They are equal, right? So you have angle E being equal to angle E because it is a common angle. So now we can rearrange the letters of our triangles so that their angles correspond, so that we can prove that they are similar. So in triangle something and triangle something, we have angle E corresponding with angle E. So we have E and E. We have C corresponding with A, C corresponding with A. So we have ECB, right? ECB. B corresponds with angle D. So it must be D here. So now we have moved from the random arrangement of our angles that defined our triangles to the way that the letters are arranged so that their angles correspond. So now we can prove that they are similar. We have Angle E is equal to angle E because this is a common angle. The second reason we have angle C is equal to angle A. We prove this by using the opposite exterior angle of a cyclic quad. Exterior angle of cyclic quad. And our third reason we have angle D is equal to angle B2. We figure this out by using the exterior angle of a cyclic quad. We said exterior angle of a cyclic quad. Therefore, we can conclude that triangle in this order ECB is similar to triangle EAD. And now from here we can then prove that the ratio of this pair of sides will be equal to the ratio of this pair of sides. So from here we can take out all the corresponding sides of our two angles, of our two triangles. So we have side EC divided by side EA is proportional to side CB divided by side AD is also proportional to side AB divided by side ED. Now we need to write the reason. So the reason we are able to state this is because these are the corresponding sides of our two triangles that are in the same proportion. We say they are in the same proportion, but we haven't proved it. Well, whenever you have two triangles that are equiangular with one another, meaning this angle from this triangle is equal to this angle from this triangle and all other three angles, then those triangles are similar. And whenever you have similar triangles, we forgot to state the reason here. Angle. Whenever you have two triangles that have the same exact that have three equal angles, then those triangles are similar, right? And whenever you have similar triangles, then their corresponding sides are in the same proportion. So from this we need to take out the pair that's going to help us prove this. So we have EA CE, EC, AD, we have AD, BC. Oh, so we're going to take this pair. So we have EC divided by EA is proportional to CB divided by AD. Now, is this the same as what they asked us to prove? No, it's not. So what we have here is not exactly the same as what we have here. What we need to make AE a numerator and AD also needs to be a numerator, so we need to rearrange this. So let's cross multiply. We have EC multiplied by AD is equal to EA multiplied by CB. Now we need to make AD a numerator, so we divide EC to get rid of EC, divide by EC. So this EC cancels with this EC. We have AD divided by 1 is equal to, because we will be left with 1 on the as our denominator, is equal to EA multiplied by CB divided by EC. Now we need to make EA our numerator, so we need to get rid of CB. For us to get rid of CB, we multiply this whole thing by 1 over CB, so that so that this CB cancels with this CB, and what we do on the right hand side we also do on the left hand side. So we'll be having 1 times AD is AD divided by BC is equal to, on this side we will be left with AE divided by CE. So we just need to rewrite this. So we have AE divided by CE is proportional to AD divided by BC. So this is the same as what they asked us to prove. So we have proven that this pair of sides, the ratio of this pair of sides is equal to the ratio of this pair of sides, and they didn't tell us which triangles were they referring to, and they didn't give us their corresponding angles. So in order for you to prove this, you need to find out which triangles are they referring to from your diagram, and you need to rearrange the letters of each triangle to align all your corresponding angles accordingly, so that you can prove that the two triangles are similar. And since you would have rearranged your angles in a corresponding manner, then from that you can take out all the corresponding sides of your two triangles, and then from this you can take out the pair that you're going to use to prove what they asked you to prove. So this is not easy, man, but I hope this video is helpful. Thank you for watching.